Hello, everyone. My name is Nalin Kamath, and I am doctoral candidate number 11 in the USS2 consortium. I'm currently at the University of Bristol, working under Professor Anthony Croxford. The title of my project is Embedded Wireless Sensor Devices for Monitoring Composite Components. And as you can probably guess, the main objective of this project is to embed wireless ultrasonic sensors as provided by InductoSense, basically these black patches, into composite components. I will now briefly provide a demo of the WAN system currently in use by InductoSense. You probably have noticed this metal plate has been divided into 4 regions, each with a progressively lower thickness. And over each region, InductoSense sensor has been mounted, surface mounted. Now, what happens when I hold a probe over a given region? Now, as you probably can notice, the sensor is able to quite accurately measure the thickness over the region where it was mounted. This proves especially useful for certain applications like corrosion monitoring. However, in addition to thickness measurements, the InductoSense sensor can also be used in order to detect cracks and other defects in otherwise pristine structures. Now, why is it important to embed sensors into composites, you may ask? Well, in addition to cracks, voids, and porosities incurred in the manufacturing process, composites suffer from a unique failure mode known as delamination, which is when the layers that make up the material separate from each other. This can lead to catastrophic consequences such as airplane crashes, as well as a prominent example that occurred last year, the OceanGate submarine implosion. The purpose of embedding the sensors is to shield them from physical damage and abrasions that arise during the normal operation of the structures they are mounted on. Again, remember, you're talking about airplanes, ships, submarines, and cars. Furthermore, they also offer ease of operation since permanently installed sensors don't require adhesives to mount and offer fast, repeatable, and reliable measurements. Research at the University of Bristol has indicated that embedded sensors can detect even smaller defects in their surface-mounted counterparts. The main tasks and challenges of my project are to compensate for sensor probe misalignment, as well as electrical attenuation in electrically conductive materials, such as carbon fiber composites. This is due to the fact that the WAN system works through inductive power transfer. That means there's a coil in the probe, so there's a coil in the sensor. And if the sensor and the probe aren't perfectly aligned with each other, or if they are separated by a conductor material, such as carbon fiber composites, the measurement quality will be adversely affected. Furthermore, I will also try to compensate for environmental and operational conditions. This mainly denotes temperature fluctuations, but it can also include other conditions that occur in normal operation of the structure in which the sensors are embedded in. Finally, I will find ways to optimally embed sensors into composites so as to ensure the structural integrity of the structure they are embedded in. I look forward to publishing the results of my work and to keep you all updated. Until then, see you